Welcome to springlib.
Once again, welcome to a new problem. We're still dealing with diffraction, and this time we have a diffraction grating. It's going to have spaces, so we have a grating like that, vertical grating. And on the left side, we have incident light. So there's light that's coming in from this side, and it's incident from the left and bouncing off to the right. So we're going to call this the incident light wave. And then coming outside, we're going to call that the diffracted light wave. And from both sides, we can see that all the openings have incident light and diffracted light. And by extension, we can still have another grating just to emphasize what's happening with the process on both sides. The one thing you want to come off with is the fact that there's an angle of incidence. If you think of this as the horizontal, and there's an incident angle, and we're going to call that phi. That's the incident angle. The gap between the two openings, the gap for the opening is d, as you can recall, and of course the angle of diffraction is theta. And this is the grating we're dealing with. So this is the piece of information that's given in the problem, and these are bright fringes, and they're diffracting at an angle of theta. And so the equation that's connected to this we want to determine if theta is connected to the equation d sine of phi plus sine theta equals to m lambda. Remember, lambda is the wavelength, and m is the order. In this instance, m can stand for 0, 1. These are all integers for m. And of course, we want to see what happens when phi equals to 0. We want to see that. So we're going to jump onto the next page. And for diffraction, we're going to say for diffraction to happen, the path difference between two adjacent, we're going to call it adjacent rays going through the slits. And think of these as the slits. These are your slits. So, we're saying that the diffraction, that the path difference between two adjacent rays going through the slits is the integral multiple of the wavelength of light used. So that's the condition we're having here. So on the next page, we're saying that delta x stands for the distance between two adjacent light rays, or rays of light, if you want to call it that. And so delta x equals to d sine phi plus d sine theta, d sine phi, d sine theta. I know you're thinking, oh, how did you get d sine phi, d sine theta? If this is a triangle, just going back to emphasize, if this happened to be a triangle and this angle is phi, so it means, and this is D, for example, and the reason why it's D is if you think of this as your opening, this is your opening, that's going to be D. So, and maybe we want to call this the hypotenuse. Okay, we want to call this the hypotenuse. We're going to call it delta x. So we're saying delta x all over D. We're emphasizing that. Delta x all over D is the same as sine of phi. So delta x has to be sine of, has to be D sine of phi. And the same thing applies to the theta. So on the opposite side, remember theta opens up and goes like that. This is theta. This opening is D. That's an opening. That's D. And this is another delta x. So you're saying that delta x all over D is sine of theta. So delta x, maybe we can call this x1. And this is x2, so delta x2 equals to d sine theta. So you're combining the two, delta x1 and delta x2, and that's going to give you delta x. That's the distance between two adjacent light rays, the distance between two adjacent light rays. So if we jump on to the next page, we have delta x equals to d sine phi plus d sine theta. So for the bright conditions, we know that delta x equals to m lambda. Those are for the bright conditions where m equals to 0, 1, 2, 3, and so on and so forth. And so d sine of 5 plus sine of theta, which is exactly the same as delta x. If you expand this, you're going to get delta x. So this is exactly the same as that. That's the same as m lambda. So this is delta x, it's the same as m lambda. So if phi is 0, it means that sine of phi is sine of 0, which is just 0. So it follows that d sine of theta equals to m lambda. And the reason why that happens is whenever sine of phi is 0, if you plug that in right here, you make this 0, you end up with d sine theta equals to m lambda. So hope you enjoyed the problem. Feel free to send any questions or comments and have a wonderful day.